We just missed the recording of the whole equation of the line.
Just make that with two apostrophes rather than the two, otherwise that implies it's y squared.
Oh, yeah. Just a second. I got distracted with the recording part. Yes. So he's right. Either two apostrophes or like so. But usually we do prime.
Otherwise it's kind of
Yeah.
unclear way.
Like so. Let's find the second derivative of the 3/7 x to the 4/3. The first derivative is, this is the power rule. Who wants to tell me? Who is ready to take this test like today? Come on, you have to be like confident. Anyone else? Chris is always ready. He's like, this active person. Okay, Chris, tell me.
Well, it's 12, well, it would be 12, since 4/3 times 3/7, that's 12/21, or reduces to 4/7.
4/3, 3/7 times 4/3, because 4/3 going down. X raised to what?
To the 1/3.
How did you get 1/3?
4/3 minus 1, which is equal to 4/3 minus 3/3.
Exactly, 1/3. This is how I also count in my head. 4/3 minus 3/3 is 1/3. Do you all agree? And now, either how Chris said, you can simplify it, or you can actually keep going. The second derivative will be, look at that, 3/7, 4/3, and now it's 1/3, because it's also have to go down, right? X to the what? 1/3 minus 3/3 is negative 2/3. And keep going like so. So at some point you will even see the pattern. So I would simplify, of course, because it's easier to grade if you do that. But for the computer, for example, you don't have to. So it's going to be 4/21 x to the negative 2/3. This is a very good answer. No need to do anything else. Can you do that? Second derivative, third derivative. Sometimes we don't tell you that take a second derivative. We tell you to find acceleration from the given distance. That is the same thing. This is a of t usually with the given s of t usually. How do you find? You find velocity. And then you find acceleration. So either or, we can hide this meaning behind the keywords, acceleration and velocity. You should know that. Let's do one more. Let's see. Let's not take too much time. One more example. Trigonometric functions are going to be on a test. Y equals tangent of 2x. Find y prime. Solution. Tangent. You need to remember. I don't require you to remember derivative, so I can write down what I expect you to know. Derivative of sine is everyone. Sine. Derivative of tangent.
6 squared.
Derivative of secant. Secant x tangent. On the exam that the coordinator gave me, she asked to find derivative of cosecant. I will not put it there. I will put these four. These four are good enough. So know these four and you are safe to go. Okay? And I think it's doable. I remember, you can remember too. I don't have a good memory, by the way. So if I did it, you can do it too. Y equals derivative of tangent, we just agreed, is secant squared, but not x. You have to copy 2x, right? You remember, you copy the function inside. This is chain rule.
And this is y prime.
Right? That is, thank you, y prime, secant squared of 2x. And then times, and what should I do? Multiplied by 2. And that is what you should remember. Sine of 2x gives you cosine 2x times 2. Cosine of 7x gives you minus sine of 7x times 7. So pi x, that constant pops out, basically. Now let's do second derivative. And that is interesting. Now we have chain rule twice. See why? There's a 2x inside of the secant, but secant is inside of the polynomial because secant is raised to the second power. So what I need to differentiate is 2 secant of 2x raised to the second power. This is a Russian doll with a small u inside, then v, and v is squared and multiplied by 2. Chain rule twice. You need to know how to do this. The very last function is power rule. You need to know what is the very last step. This is the one you differentiate first. 2 multiplied by something squared. That is 2. 2 goes down. 2 goes down. This something raised to 1. Makes sense? That something I'm talking about is v. V is secant. You cannot touch it until you finish the power rule, the differentiation of the function inside, and the black 2, the first 2, survived because it was multiplied. Times, let's put in red. Times, now I can look one step inside and I see secant of something. Derivative of secant is secant times tangent. Remember, secant likes itself, so it copies itself and then gives you tangent. But it has something inside. I have to copy that part. 2x. 2x. This is a tricky part. How do you feel about that? So this was derivative of secant. Finally, the very last Russian doll looks like there's a 2x was at the very beginning inside. Derivative of 2x is 2. So 2 pops out again, but for the very last step. So the purple Russian doll was outside. That was 2v squared. V was secant, the Russian doll inside. V, what? Let's do like so. V was secant of u. And then finally, in green, u is 2x. 2x, like so. This is how you should say it. 2x. Like so. So, yeah, you could simplify. It's going to be 2 times 2 times 2, right? Let's simplify. 2 times 2 times 2 is 8. And then you have secant of 2x of 2x. So I'm going to square it. And then tangent of 2x. So secant happened twice, here and here. How about that? What do you feel about that? And that's actually kind of all you need to know. I can see in the forum you posted questions about quotient rule and chain rule. We'll help you with this. I have YouTube videos on these. I have lots of good YouTube videos actually on all of these examples. So if you go again to this announcement here, I actually made very good examples on all of these small differentiation examples. That is not me, for you to know. Come on. Since when there's a commercial on my videos? I don't even have it. Okay, fine. So I have all of these examples here. All of them with the square roots. You don't like them? I have them. I solved them step by step. With the fractions, you don't like them? I did solve it. All of them. These guys. All of these. I have very step by step solutions. And students love it. My online students recently actually just wrote me that that's a lot of work you did and you was not proudly paid for it. I was not. These, the product with powers, the fractions, secant inside of sine, cosine to the 6, all of it. We just did this one, secant of 3x. So, technically speaking, the best one, you see how I start the example, you pause, do it by yourself, this one, and then you run the video and see if you do the same thing. And if you don't, you will see exactly at what moment you don't do it right. So this is really good. My students got A's on tests because of these videos, and that's why I'm happy that I made it. That was a lot of work, to be honest. And so on. So just do that. And limits algebraically, they all go to the exam. So this is on the exam, this is on the exam. And this is what we practiced on Wednesday. These guys we practiced on Wednesday. These conjugate, multiply by conjugate, and so on. And don't forget, unfortunately, there is a problem. Review. There is a problem there. Derivative. So these graphs are going to be on the test. We just copy them and put there. These are on the test. Unfortunately, there will be one problem when we're going to ask you to find derivative by the definition. Honestly, I always feel sorry about doing that, but we have to. This is going to be on a test. Piecewise functions, are they continuous or not? We did them on Wednesday. But what I'm talking about is, we also did on Wednesday derivative by the definition. You have to do it at least once, you have to do it. It's also on the review, so you can look at that. Okay, questions before we do the quiz? So honestly, I gave you all the materials. Everything is there. You just need to find time. Average rate of change is there. You just need to find time and actually practice it. Then I promise you, you're gonna do an amazing job if you do that. Here's the equation of the tangent line. Okay, let's do it.
Sorry,